Hey students, Dr. Ramon Flores here, coming to you from the Surface Warfare Engineering Facility at Naval Base, Ventura County. Today we're doing our virtual tour of the vertical launch system. This is a 3-story tall launcher. As you can tell, we are at the very top. So we're gonna go inside, proceed from level 1, level 2, and then finish up at level 3 right back here. So let's go inside, students. Hey everybody, and we're back. So this is the start of the tour. This is the bottom of the launcher. Again, 2 modules, 1 module here, 1 module here. If you recall from the schematic that I showed you earlier, there's actually 4 modules per launcher. What you can see here are where the different cells come in for the different canisters, and each canister would hold anywhere from 1 to 4 missiles, depending on the type of missile that we are carrying. And operationally, the way it would work is once the rocket engine launches, the exhaust from the missile comes out to this bottom part, gets collected in this area down here, and then through this uptake channel gets vented all the way up to the atmosphere, and with that we have a missile launch. So this is the very, very bottom of the launcher. Again, for sense of perspective, roughly 3 stories tall. So with that, we'll cover the rest of the sections upstairs. All right, students, welcome back. We are at the second part of the tour. This is the motor control panel. It's one of the main components that our engineers and scientists will do some troubleshooting when they are on board the ships doing diagnostics on these launchers. Again, as a reminder, module number 1, module number 2, side by side. And what I want to do is kind of highlight a couple of things. So coming in here, we've got this umbilical cord, and this is right now connected to the bulkhead, but normally we've connected to the canister here, which itself would house anywhere from 1 to 4 missiles, depending on the type of system that we have. And so this is the mechanism through which the missiles inside receive all their signals from the other components. The launch sequencer, which we'll show you a little later on, and then the launch control unit, which will be our final stop in the tour. This is the motor control panel. Again, this controls the different hatches, different valves that are used to operate this launcher. One of the main areas that we do our troubleshooting, but again, hopefully you can get a feel for how snug it is. This is actually representative of the space that our engineers and scientists have to work on when they go on board the ships. Then we're back. This is the next level of the launcher. Again, 2 modules, module 1, module 2. This next item is the launch sequencer. This is actually the brains of the entire launcher. And again, I want to show you how our engineers and scientists would go on board the ships and actually work on these things. As I mentioned, we do a lot of diagnostics, a lot of troubleshooting, but the idea is more of a remove and replace mentality. So we would open this up through our diagnostics, identify which circuit card of these many assemblies we would have to take out. Come in, take out the circuit card, replace it, close it up, rerun diagnostics, and hope that that solved whatever the problem was that it solved. And we're back to the final component of the tour. This is the launch control unit. Specifically, this is the ANUYK-44 data processing set. And because we have to have cute names for everything in the military, we call this the YUK-44 data processor. So a big picture, the way this thing would operate is the ship's radar would identify that the bad guy had shot a missile at us. It would identify, okay, which launcher, forward or back on the ship. Within that launcher, which modules, as again, we showed you 2 of those, and then within those modules, which missile. So it would say something like forward launcher, module 1, cell 1, fire the missile. All those signals would come to this computer. It would process all that information and then relay it over to the launch sequencer that we just finished showing you. Using the umbilical cord, it would interface to the missile, and then now we know, okay, missile 1, cell 1, forward launcher needs to go off, and off it goes. Real quick on this computer, it actually has 256 kilobytes of memory. Just for reference, if you have a cell phone, most of your phones operate in gigabytes worth of memory. And if you remember from your math, it goes gigabytes, megabytes, kilobytes. The idea there is I can replace this phone every 2 years. This computer is going to stay on board our ships for about 20 to 25 years. So very small amount of memory, but very reliable, very rugged, and it's like I said, it's going to be in the fleet for a long, long time. This missile launcher, just to wrap up, has been in the fleet since the 80s. It continues to support our sailors and Marines today and into the future. And we anticipate that this system will be installed in future ships well into 20 years into our future. Hey students, welcome back. So we are at the very top of the launcher. If you recall, we started from the first floor, went to the second, went to the third, went to the launch control unit where we have our computers, and now we are at the very top. This is what you would see from the surface of the ship. These are the various hatches. As you recall, each hatch has one canister. Each canister has between 1 or 4 missiles, depending on the configuration. This is the uptake hatch, so a typical launch sequence. This uptake hatch opens, one of these hatches comes on, missile gets ignited, and the flame would come out the uptake like I showed you through here. Missile comes out to here, and then we have missile away. So with that, students, this concludes our tour of the vertical launch system. We hope you would enjoy it. We will see you back in class shortly.